Every business has an audience. If you do not understand that audience, you don't know how to operate. You don't know what products to build, you don't know how to talk to them, you don't know how to grow your business.
The biggest challenge for businesses today is the complex landscape that they have to compete within. Even a tiny brand is competing on a global stage, and the market's moving so much faster than it ever has been. So how do they deliver against that?
So we exist to help our customers understand their audiences, and we do that by running research at massive scale, and we put it into a platform that anyone can use and anyone can find compelling, simple insights that can drive and scale their business.
Now there's so much more of an onus on understanding audiences based around interests. So rather than males, 25 to 34s, you might want to understand gamers. If you were to look at GWI's data on gamers, you would see that that audience is so much richer and more diverse than you might expect. There's a really interesting gender balance, there's engagement among all age groups, so it's an audience that challenges your preconceptions because you've come at them from their interests rather than their demographics. GWI allows us to speak to millions of consumers each year across a huge range of countries. We are in 47 markets, speaking to consumers every day about what they're doing and why they're doing it.
The new GWI was designed to address exactly the challenge of getting granular audience insights quickly and embedding them in day-to-day of the organisation.
For quite a long time, data like ours had been the preserve of research experts who had to know how to use it, had to know various background and context. Our aim is to put that data into the hands of everyone to help them make the best informed, most insight-driven decisions they can.
When we say a platform for everyone, we literally mean a place where anyone who needs to get insight about the audience can log in and access it directly. And the reason we believe that's important is that in order for audience insights to really be impactful, they have to be embedded in daily decision-making at every level of the organisation.
The new GWI is about empowering your organisation to be truly data-driven, enabling any business of any scale, anywhere in the world, to be able to create really exciting, meaningful insights.
Thank you so much, Sarah. Thank you, everyone, for being here. All I need now is my computer to show up on the screen, because that's not my slide. There we go. Sweet. All right. Thank you for the introduction. Thank you all for being here, and thank you for having me here in Athens. This is the first time I've ever been here, so very excited for this. My name is Nash. I am a developer advocate at a company called Sonar. Sonar, if you don't know, build tools like Sonar Cube and Sonar Cloud and Sonar Lint, which are all things that help you write better, cleaner code. We'll see a little bit of some of this later. But otherwise, if you are interested in following me at all or ever want to ask questions, find me online anywhere. I'm under the handle Phil Nash, wherever you can find it. Yeah, that's as easy as it is. So let's get on with it. I want to start with the data. So when I say the top 5 issues in all of our JavaScript, I do actually mean we have data on this, which is cool. So I work for Sonar, and we have Sonar Cloud, which is a software as a solution based coding analyzer, static analysis. It has well over 300 rules for different JavaScript things, and we have hundreds of millions of lines of JavaScript that live inside that project. And so I just went to the team and said, hey, can you just tell me what the worst things are? Like, what's in every project? And they gave me back a CSV with all the data on that, which is very nice. And so this is that top 5 from there. And so you'll probably recognize these things in your own code, but let me tell you, I'm not here to tell you you're doing a bad job. I'm just here to say that we should be able to recognize these things and change them when it's appropriate. So I'm not having a go, I promise you I'm not having a go at you. That's what I mean by JavaScript issues. It's those kind of rules and linting things that you might have set up against your projects, and that's what we're going to go through today. And we're kind of talking about clean code in this case. And clean code, for me, is something that is workable, is usable when we're both maintaining it. Stuff that is easy to write with, easy to change, easy to test. But also stuff that then works in production as well. That's what we're kind of talking about in terms of clean code. Maintainability is always something I think that's very important to me, because I hate opening up a legacy code base that you don't really understand, and then it takes forever to read through the entire code just to find out what it does before you can make a change. And then when you make a change, it breaks something somewhere and you don't know what's happening. So if we write clean code, we don't have to do that. We never end up with a legacy project, and isn't that the dream? You see, There's a couple of quotes about this. This is one of my favorites. From back in 1991, a C++ games developer called John F. Wood said, "Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live." Code for readability. There's a round of applause for that. He was talking about C++ at the time, who I believe is made up entirely of violent psychopaths. But funny enough, this was actually on a mailing list, and the discussion that surrounded that quote was about the comma operator. And somebody was suggesting that code could be cleaner if we use the comma operator to do more than one thing on a line of code, particularly within a conditional like this, because it means you get to drop the braces from the outside. And this is C++ code, but frankly, it could also be JavaScript code, right? This is almost exactly what they had. And you know the problem here, right? The problem is you typo something one time accidentally, you put a semicolon in, and I know somebody was against semicolons earlier. But you put a semicolon in, and sure, this syntax highlighting is showing it, but they were talking about this in 1991, where they still had to scratch their programs into clay tablets. And you can't go searching for a little thing like that and find out what's happened. So that just makes it anti-maintainable. If you're trying to improve something by like reducing brackets, but you make it more brittle. I then liked this quote. This is from Raymond Chen on a Microsoft blog, where he said design for readability. Now, John F. Wood said code for readability. This says design for readability. And he says, even if you don't intend anybody else to read your code, there's still a very good chance that somebody will have to stare at your code and figure out what it does. And that person is probably going to be you 12 months from now. In this scenario, you're now the violent psychopath, and you don't just know where you live, you know exactly where you are right now. And you can have a go at yourself. So writing clean code, clean and maintainable code, just makes things better for the future for ourselves. So it runs better in production, but it's so much better to maintain. That's what we're aiming for here. So what are these top 5 issues? Well, I'll be honest, I'm not going to go from 5 to 1 in order, because that turned out to be boring. I'm going to go in some sort of order. And I also added confetti to my slides to make some of them seem more exciting, because the problem with the top 5 issues and anything is that they're very common. You're not going to find too many surprises here. So where should we start with? We will start with number 5. Our number 5th top issue, out of 300 odd issues that there could be, is unused assignments should be removed. This is fairly straightforward, but you probably find some of this in your code base somewhere accidentally. It's not necessarily breaking something, it's just useless code. If you assign something and then reassign it to something else later, that first line isn't doing anything. And when you're reading this code to understand what it's trying to do, if you read an assignment and then you read another assignment sometime later, and they're not necessarily next to each other like this, you have to understand why that was there in the first place and then discard it. So not assigning things that shouldn't be assigned is a good thing, and having a tool to kind of point that out to you is kind of useful as well. This is another example of how that could happen. In this case, we just don't do anything. This is an assignment that never gets used. We assign and then we get out of the function and we're done with. That's a block scoped variable that we didn't do anything with. Again, easy to see in a 3-line function, but if your function is 30 lines long, it would be better if it was 29 lines that all did something. And then finally, I've seen stuff like this in people's code bases, where that result variable is kind of set somewhere outside of the scope of this function, and returning the result of the function whilst also setting it to some other variable. That's really odd behavior, in my opinion. I've seen it so many places. Like this is the definition of side effects in a function, and non-determinability when it comes to the rest of our code. Functions like this, an adding function, should be a pure thing that always do the same thing and don't cause side effects outside. So that's unused assignments. Get rid of them. That's a good start. Nice and easy. Let's move it on, though. A little more confetti. Triple equals and double equals. Who's a fan of I always forget the word. Coercing things for equality? Yes, you are a fan of that. This is my favorite thing for equals and double equals and triple equals. This is a grid of equality when you're using double equals between a bunch of stuff. And you can see down the right and left-hand side here, we've got sort of true, false, 1, 0. And this green line down the middle is where they're the same thing, i.e. they're equal. And these other green boxes are the random assortment of things you have to remember that they could be equal to. You know, like the string 1 is equal to true, the string 0 is not equal to true. It makes no sense. And it's so much easier to remember this one, triple equals. And obviously it's double not equals as well. There's no good reason, in my mind, to have to type coerce things for equality. If they're not the same type, they're not equal. Your further issue with that is that double equals, when it's coercing types, particularly of large objects, runs about 1,000 times slower than triple equals. So if you do that in a hot loop, you're going to cause yourself some performance issues too. So I think we can agree double equals can be out. Let's keep triple equals for everything. Hurrah. In at number 3, we have, I can't even remember now. What was it? Yeah, we go. Okay, sections of code should not be commented out. Now, we started with some useless bits of code, assignments that never did anything, or assignments that got reassigned. And that's code that exists in our functions, but doesn't do anything. Commented out code, that exists inside our functions, and it looks like it did something at one time. And I find if I ever find a function or a class or something that I have to read where there's commented out code, I also find myself parsing and reading the commented out code to see what that does as well. And that's no good. We're trying to maintain this. I talked about earlier, like legacy code is that stuff that it takes you forever to read and understand. If you have to read and understand code that's not even going to run, that's a nightmare. And so there's not much more to say about this, other than use your version control software, use Git or whatever it is. If you think you need to save some code for later use, it should be in your history. It shouldn't be laying about inside your code. Cool. So I'm not going to go to number 2 right now, because number 2 is my favorite. So instead, let's have a look at number 1. Has anybody got any guesses for what the top issue in JavaScript codebases could be? It's going to be a really obvious one. Types? As in not using TypeScript? No. No. It's not types. Yes, spot on. Now, I'm sure, again, this is a legacy in terms of time rather than legacy in terms of just writing bad code kind of issue. But the largest... hello, my screen's gone. It's still here. It doesn't matter. We can keep talking about this for a while whilst they fix that. Using var is a holdback to when we didn't have let and const, and that's fine. But the only reason we should be changing and updating our vars to lets and consts is for that readability and communication. You see, var doesn't really tell us anything about what we're doing with a variable. It tells us we might be expecting this to be hoisted. It tells us that it doesn't necessarily live in this scope, it can live in other scopes. It's a bit of a nightmare. But let and const actually give us a bit more direction. They are block scoped. It's only within these brackets that it matters. And thank you. And let says, I'm going to change the reference to this, and const says this reference is not going to change. Let and const are just about communication to yourself as a developer and to your teammates and anybody else reading that code. And so I don't blame everybody for having var stuck in their old code bases, but we can bring it up to date as we cover that code. If we ever go back to change it, we can improve it by changing this communication. Okay, cool. I really like those 4. Like I said, they're fairly straightforward, and these are things I think we could actually change quite easily, which is why I left number 2 until last. You see, number 2, the second biggest problem that we found in JavaScript codebases is that the cognitive complexity of our JavaScript functions is too high. Now, I know you're all thinking, woo, exactly. What? It's, I guess, maybe I put too much confetti on this one. Calm down. There we go, okay. Does anybody know what cognitive complexity is as a measurement of code? That's it. There's one. Shout out. Any idea? Or, almost. So that's cyclomatic complexity. Which is on my next slide. So good work. You're helping out. Thank you, Josh. Cyclomatic complexity gives us a score for functions that counts up, how many branches there are, how many different ways you can go through a piece of code. And this score is come up with, as you can see in this example, which is summing prime numbers, by adding 1 for our existing function. And then as we hit a for loop, that's going to add 1. We end up with a conditional, a nested conditional. That's another 1. We have another for loop. We have another conditional. And the score is 5. And that's fine. It's a nice measure, like I say, of paths through a piece of code. It kind of gives you a number for how many tests you need to write to cover everything. But it doesn't exactly feel great, and this score has been around for a while, but it doesn't feel great when you see it next to a function like this. So previously we have sum of prime numbers, 2 loops, 2 conditionals, something inherently complex. And on this function we have a getWords function that returns sort of a noun for 1, a couple, a few, many, or lots. And this is a big switch statement. But the way cyclomatic complexity works, because each branch of that switch must be tested, it also scores 4 points for the switch, as well as 1 point for being a function. And these two are equivalent to cyclomatic complexity. But reading this one is much easier than reading something with 2 nested loops and conditionals. And so cyclomatic complexity, measures the way through a code, the number of paths. And cognitive complexity is a measure that we actually came up with at Sonar back in 2016. It's been around for quite a while. That measures how easy it is to understand and maintain a function. Cognitive complexity creates the same score, well, not the same score, sorry, creates a score and does so in 2 methods that is slightly different cognitive complexity. So what it's going to do is increment for breaks in flow, that is a loop and conditional, like we saw, and it's also going to increment a nesting score in the background. Then if there's another break in flow that's already nested, it gets incremented by 1 plus the nesting score. And so that looks like this in our sum of prime numbers. We drop the scoring a point for being a function, because everything's a function. But we score 1 for our for loop. And then in the background, we increment the nesting score to 1 as well. And then when we get to our second nested for loop, where is it? Here. We get to that second nested for loop, we have this nesting score of 1 as well, so this scores 2. Then we go inside that loop, we have a conditional, and that's going to score 1 plus 2 for the current nesting. Then we get out of the loop eventually, we have 1 more conditional, so that one also scores 2, ultimately giving this a total cognitive complexity of 8. Meanwhile, getWords scores 1 for it being a switch. And that feels better in terms of when you're looking at how easy it is to understand and maintain a function, this one is definitely easier than the sum of prime numbers, and that's fine. So the cognitive complexity of functions should not be too high is the rule that is being failed by many JavaScript projects. But too high in this case is 15. It's sort of an arbitrary number, but that's fine, because arbitrary numbers, it's a good high-level number. I found it difficult to write a function that was complicated enough just for an example. But what it says is we should have a look at this. And I want to give you a quick example. I actually wrote the confetti-throwing plugin for Reveal.js so that I could throw confetti on my page. And it turned out I had written it in a very complicated way. And as you can see, here in my editor in VS Code, I've got a red underline for this thing saying, hey, the cognitive complexity of this function is 16, higher than 15. And you can kind of see why. We've got a big conditional around the outside. We have some ternaries here. We've got another conditional. We've got more conditionals. We've got a request animation frame loop. We've got a big settings thing here. It's an 87-line function. It's a bit complex. And so when this triggers, it kind of says to me, hey, you should go and look at this now. You've been working on this function for a while. Maybe people have been adding bits to it. You should go in and have a look. And if you use, so this is disconnected from the internet, so it's not going to show me the cool stuff. That's fine. So the idea is we should be able to refactor this. And so one thing we might do is refactor a way of getting dataset attributes out and turning them into an integer. Now, this kind of thing is abstracting this line here. We're getting a particle count, the number of pieces of confetti to throw on screen, or a default, 200. And so if we write the function integer data attribute or default, then we can replace that. We still have the ternary, we still have this conditional, but inside the function, if we just add that there, then the function becomes more obvious what it's doing. You don't have to understand the ternary now. You just have to understand we're getting an integer from a data attribute or a default. And you can keep doing this. This is actually fixed to the cognitive complexity. It's now not more than 15. But because we started looking at a function like this, we can say, hey, we've actually got more of these things which we could fix. And so ultimately, if you fully refactored it, a refactoring of it might look like this, where you pull out those ternary operators into things. Some of these are repeated functionality as well. We have a function for each of the types of confetti throwing things. And then eventually, the entire function fits on my screen. And that's with the font size of 26. So this is much more understandable. We now know that we're getting things out of data attributes. We now know that if we do a small confetti, we just call the small confetti function. And if we need to dig down into that, we can then just go and understand what's happening in one of those functions instead. So with something like cognitive complexity, and the arbitrary kind of level of 15 as an attribute, we can determine when functions get overly complex, and then we can pull them back, fix them, and so that when we come to maintain this code again in the future, it's going to be easier to read and understand. So that's cognitive complexity. It turned out it was the second biggest issue that we found in JavaScript projects, and I'd like to see the cognitive complexity of everything kind of reduce. I hate reading things and not understanding them the first time. And so I'd love if you'd come with me on the journey and fix all of these things, but actually make those functions smaller and more easy to understand and maintain. If you want to use some tools for this, then Sonar Cloud and Sonar Cube are things that are going to sit in your CI/CD pipelines and tell you when you're doing these things wrong. And SonarLint sits in your editor. It's free and you don't have to worry about anything else. It just likes connecting to the internet. Otherwise, I've shown some good stuff that it can do there. Of course, you don't have to use that, and ESLint is absolutely available for you, though it won't tell you about cognitive complexity. You can have it tell you about cyclomatic complexity. But there is a Sonar plugin for ESLint, which also includes cognitive complexity. So if ESLint is already part of your project, check out the ESLint plugin Sonar.js. And then finally, I will share these links out later on my Twitter and other social media. The cognitive complexity paper is the only computer science paper I've read more than once. And it was a lovely read and tells me a lot about all of this stuff and goes into more depth in things. That's just a link to the Raymond Chen article on coding for readability. And then if you do want to look into all the different other rules that could have failed the tests today, the Sonar JavaScript rules will be linked as well. And then finally, I did open source the confetti plugin. So if you ever want to give a plugin and throw confetti on your screen, that's also there on my GitHub. So that's all I've got time for today. I want to encourage everybody to consider cleaning up your code. And by that, I don't mean we all have to drop everything we're doing and change all these things in our projects. But if you're working on something and you come across something that could be better, just make it better as you go. If you do that, ultimately your project will either entirely kind of clean up, or if you never touch code, it's fine because you never touch it. Refactor those complex functions, code for readability, code for your future self. That's all I ask of you, code for your future self. Again, my name's Nash. I'm a developer evangelist a developer advocate at Sonar. It's been an absolute pleasure talking to you today. Thank you so much.